diversity and social good aspect of data science. I just wanted to put a little plug in here from some work that we do that may be a little different than what you think of when you think of data science. So I think a lot of the times when we think data science, we think like Google or Amazon, these sort of big tech companies, or like heavy scientific research. But one of the things that we do in mine and Holly's department is we actually volunteer our time to work with local community centers and non-for-profit organizations, and we help them see if they have data they can use to better help their processes, and sort of help them grow as a company, even if it's just on a small scale, even if it's just a local company in Ann Arbor. So I know we're getting a little over on time, but these are just 3 projects that I just happen to have worked on in the past year with this group, and I think it sort of speaks to the diversity and things that you can do in this field. So I don't know how many of you are familiar with Ann Arbor, but Ann Arbor has a community foundation. And one of the things that they did recently was they had a huge grant where they were trying to figure out how to allocate a lot of money to help senior citizens. So these are like things with them getting meals or, you know, in-house care, being bathed, being transported for doctor's appointments, things like that. And it's really our job to figure out where they have the most need, where can this go, how can this money be used best. Similarly, we worked on a project in Toledo, Ohio, where they sort of have these mobile food pantries that drive around Toledo and deliver food. The question is, you know, where's the best place to be driving? Sort of looking at Toledo as this large city, like where can we go to impact the most need? Where can we help the most people in the smallest area? Another thing that we worked on was there's a children's center here in Ann Arbor that has a lot of crisis calls from like high-risk youth. So these are children who are homeless or who have run away from home. They don't have good home lives. They don't have a good home situation. And really, there's such limited resources here that they have to have counselors on staff 24 hours a day. And it's how do you balance that? We're making sure that the counselors are there at the right times to be able to help these kids in need. So these are just 3 examples. This is just in the past year, projects that my department has worked on. And this is not for academic credit. No one was paid. This is just purely because we have the skills and we saw the need. So I just wanted to sort of plug that as you're thinking about what you can do as a data scientist. It doesn't have to be working for a big tech company. It doesn't have to be doing medical research. Data is everywhere, and data can be used for so many different things. And these are just 3 examples, and we're going to get into some more detailed examples later, but just how data is so crucial. So here we have 3 questions, we have 3 needs, and with the data that these non-for-profits already had, we were able to answer these questions and help them better the community around us. So I think maybe we can go on to like some specifics. So I'll talk about this when we each sort of have a project that we wanted to talk about. This is another one that I'm working on currently, which I just think is such an amazing project. So I'm sure, is everyone familiar with Flint, Michigan and everything that's happening in Flint right now, or that has been happening for the past few years with the water crisis? There's been huge fallout from this, just the mistrust and the misinformation and how people were just lied to about their health and well-being. And so what people in Flint have done is they have this survey, this community survey that they now have been releasing it since 2003 every 2 years, but now they have really put a lot of focus on the Flint water crisis. And really what this survey does is it allows people to give the opportunity to say their perceptions of their health, how their health and well-being is in their community and their built environment, with respect to the water crisis, with respect to their income, you know, their access to food and medication. And this is really giving a voice to people that otherwise wouldn't be heard. Really the goal of this project is to understand the health and well-being of the people in Flint. And it's a very complex survey, and I won't go into the details, but in statistics, there's a whole bunch of considerations that go around having a survey that you can get good data from, and that's like representative of the population that you're surveying. This is a whole area of study for people in my field, is how to create a good survey. And really we're able to collect a lot of data on the people in Flint and how they're feeling and how they've been feeling. But one of the things that I wanted to speak on this project is that all this data gets collected, but it's not accessible. So what they have done in the past is they just release this like 100-page document online, like every possible combination of the survey responses that they get. And while it's completely transparent, everybody in the public has access to it. Not everybody really understands what they're looking at, so they can't use it meaningfully. And really, this is like by the people and for the people of Flint. So what we've been doing now in my department is trying to develop a web app that's interactive, where people can actually go online, they can click on questions, they can click on how they want to see the questions, if they want to see it by different race groups, or if they want to see it by different age groups, or if they want to see it by different zip codes. It's fully interactive, like data visualization tool that we're trying to develop right now, where people can really like take ownership of the data that they've contributed to. And I think this will be really important. We're still sort of in the early phases of just summarizing all of the data and building this tool. But I think as we have a good platform, we can really start digging into really the issues with the Flint water crisis and how this has impacted the community, and how people still feel now in a time where the Flint government would say that this crisis is over. But we're still seeing such an aftermath of it that it's not over, and it probably won't be over ever, or at least not for a long time.
Okay, so next project is my project. I just want to introduce you guys to a project that but I did during the pandemic. So we got the request from, so I'm working at University of Michigan Transportation Research Institute, and we often get requests from Detroit city government or from other city government that says we have all these transportation data and how can we make use of it. And this is the one that we collaborate with the Office of Mobility in Detroit, Mobility Innovation in Detroit, and they have the data sets from Spin, which is the only scooter operator in Detroit. Oh, before that, I just want to jump in and says, because I can't see the chat window here, and so I can't see all the questions that you guys posted. If you have really good questions, and I'm sure you have, we can discuss it during the Q&A session. So let me continue. So the data set contains, what the data set looks like is they have 4 basic columns that we use, which is the location of the start points, the location of the end points, the timestamp, and what we call the unique ID to identify each of the records. So the whole project, the purpose of the whole project is to analyze the scooter, where have they traveled and when were they traveling, and where did they go to? Is it connected to a transit station? Is it connected to a grocery store? Or is it connected to, say, a movie theater or something like that? Or to identify if someone goes to a movie theater during the pandemic, or if any movie theater is still open. So the whole purpose of this project is to see if there is anything that we can do on a policy level, and says from the public sector point of view that Spin, as a scooter company, you need to do A, B, and C to make sure that we reach a equity goal, to say all the communities get equal access to scooter as a micromobility service for all of the residents in Detroit. And what we have is the start and end point of all of the trips and the timestamp. And what we need to do is to see how many of those trips start or end in a the spatial unit we use is block group. That may be a acronym that you guys are not familiar with. Let's just say it's a block, a city block. And what we need to do is to see how many trips end in a city block that has low income residents and has a high percent of African Americans, and to see if a different population or a specific population group are getting less access to these micromobility options. And if this specific group of population is underrepresented, we will say from a public sector and says we make the request or ask it SPIN to deploy more scooters into that block. That's the whole process of this project. And what we end up doing successfully is we provide a full analysis of the scooter trips and provide evidence or proofs for the city government for them to renegotiate with SPIN and develop a better scooter deployment plan to reach this equity goals and to give equal access to all of the communities in Detroit. For those of you who live in Detroit, I don't know if you feel the change of the scooter deployment or if you use scooter ever, but the outcome of this project has been proven successful, and we now see changes of the scooter trips. More scooter trips are happening in underrepresented communities now. So I just want to show all of you two quick figures that we did that I'm pretty sure that after this data camp, you will be able to do by yourself as well. So this is like a basic analysis using GeoPandas, which is a package that utilizes Python as a coding language. And what we'll do is to show how the trips, how the number of trips change during the different time of day. And there's another one that's pretty, I don't know, direct. This is the previous train of scooter trips. You can see we aggregate all of the data points to a street segment level, and you can see what which streets are busy and which streets are kind of quiet. Like you can see, I don't know if you guys can see my cursor, but on the north side of the on the north side of the city and on the west side of the city, which is pretty much the low-income communities, they're not getting any access from the scooter company. And what we did afterwards is to deploy more scooters into those areas and to help the residents there.
Okay, I'm going to talk about my project now, or one of my projects. So this project is going to kind of segue into what can go wrong with data science. So this project was designed to look at agreement between two different types of studies. So there are observational studies, and that is where a lot of the data, the big data, comes from. And in healthcare, this is when patients are not necessarily assigned a treatment based on any sort of randomization. They get what the clinician thinks that they should have based on different factors and their disease and such. And then there's also randomized clinical trials, and those are the types of trials where drugs are developed. So typically with a randomized trial, there are at least two treatments, and people are either assigned treatment A or treatment B, and those treatment assignments are totally random. And what that does is it makes those two groups of people who are receiving the treatments very similar. Whereas with observational studies, there might be different characterizations. For example, like if a person is going to either receive, a cancer patient is either going to have surgery to have the tumor taken out, or if they're going to receive chemotherapy. That treatment decision might be based on how well the physician thinks that the person could handle surgery. So people who receive surgery might be healthier than people who receive chemotherapy. And then when you're looking at the results, it might look like surgery does a lot better, but that's just because before they even received their treatment, they were already doing pretty well. So observational studies are usually a little less expensive because they don't have to be quite so regulated. And so but however, the randomized clinical trials, they can give really unbiased estimates. They can get at the true treatment effects and the treatment differences between those two treatments. So observational studies, they're cheaper, they're faster, but randomized clinical trials are considered the gold standard because they can give really good estimates of these things. So more and more, because the data is available, people are using observational studies to compare treatments. And so my collaborators wanted to look at if the results from an observational study were similar to results from a randomized clinical trial, because that would mean that we could save a lot of money and stop doing these trials or start trusting the observational results a lot more. So to do that, first we had to do a big literature review. We had to search through lots and lots of databases for randomized trials and observational studies that were looking at the same thing so we could compare the results. So that took a long time. And then we had to, because our goal was to ask, are these types of studies producing the same results? And so we had to kind of come up with, what does that mean for them to have the same results? Is that like the recommendations from the papers have the same recommendations? Does that mean that the estimates are similar even if the recommendations aren't the same? And then we had to present the results in a way that explained what we were doing and explained the differences between the types of studies. So the benefit from this project, or the end result, was that we found that these types of studies don't have the same results, and they don't often agree. So that means that the observational studies likely have other factors. The patients who are receiving the treatments have too many different factors to really be comparable. And if I was going to do this project again, I would sort of explore agreement in different ways, from the recommendations from the paper, or statistical significance, or even just the actual estimates that we got. So this is kind of a lead into the next slide that I'm going to talk about. So I'm ready for the next slide. Okay, so there's a lot of, there's so much data out there, like we were talking about before. There's there's a big number. Zettabytes. That's a lot. And a lot of that is observational data that's based on, you know, your phone collecting data on you. There's also electronic health records, which is when you go to the hospital or a doctor's office, they will digitize sort of the summary of your visit. They will have clinician notes can be digitized, the actual diagnosis, and then different factors about you, you know, if you get your height and weight and age, smoking status, etc. So we're going to think through an example. So we're going to have a wealthy Michigan hospital decides to start using electronic health records to better prioritize patient care in the emergency department. And in general, you don't want people to overutilize the emergency department. Ideally, you'd want that to be just for emergencies. But a lot of times people delay their care or can't get to see their general doctor, so they use the emergency department a little bit more regularly. So the electronic health records have data on their demographics and how many times they go to the emergency room, and if they were seen at the hospital for anything else too. And so the goal of this data science project is to minimize patients returning to the emergency room within 30 days. So we'd like to be able to get them good quality care while they're in the emergency room, and then refer them to someone to take more long-term care for them. So data scientists have developed an algorithm to prioritize patient care based on this data with this goal in mind. So we can either do in the chat, or if you want to unmute yourself, what are some advantages and disadvantages to this new data algorithm priority method? Or if you have questions about the scenario.
Hi, my name's India. I don't know if you can hear me.
Yes.
I would say like a big disadvantage is it could cause a lot of prejudice for people, and even though people can tend to go to the hospital a lot if they have a lot of concerns or something like that, if there's something more serious that's maybe not what they usually go in for, especially if they go a lot, then it can prove as a problem and as a medical risk. Just sending them back home or delaying their care for something that could be an emergency just based on an algorithm like this.
Yeah, definitely. So there might be some issues where if a person does have to legitimately go to the emergency room somewhat frequently, that might this algorithm might put that person at a disadvantage or view them as lower priority depending on what the algorithm does. Good point.
There's always problems using anything that's electronic. Stuff could mess up, things could shut down. So that's like something that should be brought into play during that as well. It could be electronic, but there should be something on paper on hand at any time.
Yeah, so if just in case something happens and the system shuts down, or if there's a power outage or the internet goes down, you'd want to be able to have some sort of backup system to take over just in case, right? What are some of the advantages for this?
It works a lot faster than hand.
Yeah.
Hi, this is Lauren. I'd say that it can reach out to more people, like it can handle larger groups, more than one person.
Yeah. So a doctor in the emergency department is very much limited by who they can see because they are just one person, whereas this algorithm can be like, okay, prioritizing all these patients all at the same time. Or even just an admin person it could do faster than just an admin person in the hospital as well. Yeah, so it can see a lot of people very quickly.
Hi, my name is Donna, and basically it can also save resources as well.
Yeah. So now instead of having people taking time to try to assess all of these things, we can just have an algorithm that will pop out the priority of this patient and what needs to be done.
This is Lauren again. I'd say another disadvantage, I just saw somebody in the chat say it's a patient-to-patient case. So I think that there are going to be outliers, like people, it may work for the majority, but there's going to be people who they just don't want them to come back. So they might just say something like, I don't know. It's just, okay, I'm just going to say another example. This company made a program that responded to people. So it was learning through data, talking to regular human beings. And in the end, it started calling people dumb and stupid because it was learning from the people it was talking to. So basically, all the information is not necessarily good. So yeah.
Yeah, so this, sorry.
Go ahead.
This algorithm is based on the data that it's receiving, which is just from this wealthy Michigan hospital. So it might prioritize patients differently based on the data that it has. So one potential problem is if they think that this algorithm is great and they try to share it with other hospitals in the area, the patient population might not be the same. And so it might cause a lot of problems. Or if there are outlier patients that come to this hospital, it might get confused and do a bad job.
Yeah, just piggybacking off of what Lauren said, medicine, like no matter what you're doing, like Pedro said, it varies. And that's why it's called a practice. So like, I feel like doing an algorithm like this is it's very difficult because you don't know what you're expecting. And like a computer can't assess a person as well as another person could that already has those experiences. And then I don't know if am saying this right, but Yana, is that how you say that? said that the advantage would be that there's no upfront bias. But if somebody sees, oh, this patient has already been here so many times, it must not be serious, or like vice versa, I think that there could be additional hidden, or like, yeah, like hidden bias right there. But yeah, I just think it's difficult to mix a whole bunch of like technological, like, hey, yo, this is what you have, or like, you've been here so many times, so we shouldn't assess you in the same way as you just walking in.
I have a question about hidden bias. So we talked about outliers, right? Like people who look very different from the normal patient population, but think about this in terms of like demographics, like where this hospital might be located. What if the issue is not about outliers, but just with how the actual patient population looks? I mean, where are the inherent biases, the hidden biases that we might see if it's maybe just one certain type of patient versus like another type of patient?
Yeah, definitely. So, Michigan, if this is a wealthy Michigan hospital, is predominantly white. And so for the different health needs for different populations, a wealthy white person is going to have different reasons for visiting the emergency room than other people might. And so who is utilizing the system and really can influence the algorithm as well.
Really important to remember that data, algorithms, and numbers, like it gives the illusion that they're unbiased, that they're somehow like the source of truth or something, but they're completely subject to the same bias as anything else, because they're so predicated on like who's interpreting them, how they're interpreting them, who is modeling them, how they're modeled. Like there's so many layers of, you know, potential areas where bias can come in, and it's just important to remember that data, like anything else, can also be biased.
Yeah, and this also goes back to when we were talking about who is practicing data science. If it's predominantly white men who have their master's degree, then those are the people who are going to be building this algorithm. And so they might not be thinking about some of the complexities of the data in the same way that a more diverse team would. So having diversity is really important for developing these types of algorithms, because everybody has their own different lived experiences, and bringing that to the even building an algorithm, which we think of as, or like to think of as, unbiased, but bringing your own perspective to that, it in itself creates a little bit of bias. So having a diverse set of people looking at an algorithm and working on it can really help make it the best that it can be. Oh, we have 5 minutes left. Okay, so can we go to the next slide? Yeah, so advantages of the electronic health record. Another positive thing is that there's a lot of data. So more data really helps a lot of times, but it's also, you know, a lot of data that is biased in its own ways. And then, yeah, algorithms can help streamline things. So an ER department that's really high pressure. Yeah, we can go to the next slide. Disadvantages, that's basically all of what we've seen. So yeah, people without health insurance are more likely to use the emergency department as sort of a regular tool in their healthcare, because they might not be able to see a primary care physician. And then also patients with severe chronic illnesses might come into the ER quite frequently for, like if a kid has asthma, they might have to go to the hospital pretty regularly to get treated, or epilepsy or something along those lines. Yeah, and then we talked about how it might inappropriately prioritize illnesses based on the population that it's seen. Okay, we can go to the next slide. So there's a lot of cases where data science has gone wrong. There's cases in, one big one is that there was a widely used healthcare algorithm that had a racial bias, where it was prioritizing Black patients as lower priority than white patients. And so that is a real situation that we were just going through. And that's caused major problems. There's also a lot of talk about facial recognition technology right now, how that has bias, and even ride sharing, Uber and Lyft charging more in non-white areas. And so this is a frequent and problem, and it's going to become a bigger problem. And that's why we need more people looking at these things and thinking through them so that we can try to understand the nuances of data science and our data better to create more just and equitable algorithms. Okay.
So Holly, before you move on, I want to kind of talk about that point. All right. So this is interesting. So when I worked for Hyundai R&D, we were doing research on ride sharing. And it is true that you do have these algorithms that charge more. But it isn't necessarily the case that the people who are building the algorithms intend for this outcome to happen.
Mm-hmm.
Their algorithms are responding to supply. And what is happening is people who are Uber and Lyft drivers are actually turning off their app when they're riding through majority Black neighborhoods, right? So this is a case of like human behavior actually driving outcomes in the app, which then propagate and end up in, unfavorable circumstances, right? So like there's this, that's something that you also have to think about when you're a data scientist. Like the work that I do, how can I make sure that the worst of society doesn't influence it in a way that has a negative output? And I've literally watched people, if you take a map of Detroit, there are people who make airport runs. They shut their app off in between the airport and downtown, and then they turn back on because they don't want to deal with any of the communities that are not downtown or midtown Detroit.
Yeah, that's a good point. We talk about the data having its own issues and who is creating the algorithms. Very few people have like bad intentions. For the healthcare algorithm, I'm sure they did not set out to create this bias, but since this is a result of what they created, it's important for them to be able to address it as well. And so for the ride sharing apps, if that's a known thing where people shut off their apps in between the airport and downtown, how can we change the algorithm to account for that with that new information? And so a lot of times these algorithms need to evolve continually to address biases that come up or issues that come up. So definitely always an iterative process.
I just want to add one point to this because we're already living in a biased world. So don't be afraid of the fact that as a data scientist that you may be creating bias. Don't be afraid of that. Sometimes you are actually making changes, which means you are change this already biased world. So don't be afraid, but be aware of your creating bias.
Mm-hmm. Mm-hmm.